This problem here gives us a piecewise function. So we have two different expressions that determine the output of this function depending on where we are on the x-axis. So if x is less than or equal to 4, we're using the expression x squared plus 2 to get our output. If x is greater than 4, then we multiply x by 4 and add 2 to get the output. So first part of this is to verify that the function f of x is continuous at 4. So in order to do that, we have to make sure that f of 4 itself is a real number. That's easy enough to get. If we look at f of x, when x is less than or equal to 4, we use the top rule. So if we evaluate the top rule for x equals 4, we're going to get 4 squared, which is 16, plus 2 gives us 18. So f of 4 exists. The next thing we need to do is make sure that the limit as x approaches 4 in the function f of x is also 18. So it's going to be our definition of continuity is that the function at a specific value of x, so in this case 4, is equivalent to the limit of that function and that as x approaches that same value, in this case 4. So to get the limit as x approaches 4, we just need to make sure the left and the right side of 4 give us the same value when we approach x as a limit. So if x is approaching 4 from the left side of 4, we're talking about values that are smaller than 4, we would use the top rule. So the closer I am to 4 from the left, the closer I am to the output I get in this expression when I plug in 4. So we already saw that gives us 18. If I was to approach 4 from the right side, we're talking about values that are larger than 4, in which case I'd be using the bottom rule. And the closer I get to 4 from the right-hand side of 4, the closer I'm going to be to 4 times 4 plus 2, which is again 18. So because f of 4 is exactly the same thing as the limit as x approaches 4, right, the left and right side are both 18, so we can simply say that as x approaches 4, independent of what side we come from, we're still getting 18. We can now say the function is continuous at x equals 4. So next up is the function differentiable at 4. And the answer is no. And the reason why is in the text, we look at 3 different areas where a function is not differentiable. So one is a discontinuity. So now we had saw that if we look at this graph at x equals 4, whether we use the top or bottom rule, we're getting 18 in either case. So like the left side of x equals 4, we have this parabola x squared plus 2, which basically looks like that. There's the point 416, we'll call it. For 4x plus 2, that's just a line, looks something like this. And again, because when I plug 4 into the bottom rule, I get another 18. These two functions will touch, so it is continuous here. So we're not dealing with a discontinuity. Like if that line had picked up down here or something, we'd have a discontinuity. But we are continuous. Another place that you can't take the derivative is at an asymptote. Now, we don't have an asymptote. We'll talk about asymptotes later in chapter 3, more specifically. But the third place is a corner point. So in this case, where x is 4, we do have a corner point. The behavior to the left and to the right is different. They're both approaching 18, whether I move from the left or the right side of x equals 4. But we have a parabola to the left, we got a line on the right. So because the behavior is completely different on either side of x equals 4, we can refer to this point specifically as a corner point, and that is a place where a function will not be differentiable. So the answer to this part B is no. This next question gives us a function, x squared minus 5x, and we need to find the simplified difference quotient for that function, and then we'll evaluate it for various values of h to complete this table. So we've got the difference quotient, looks like this, and the difference quotient is just a way of defining slope. Instead of y2 minus y1, we've got this function is y2. If we treat x as our initial x, the way I would get y1 is I would just plug in x. So the function notation for that is f of x. So this is like our 1-point output. So this is the y1, we could call it. Right. or sorry, yeah, y1. The input is just x. So here's our ordered pair in function notation, x, f of x. The other pair is, well, if h is defined as the amount of change that I observe in x. So if I started at x, if I add h to it, I get the next x. So we can think of this as x2, x sub 2. And the way you get the output is you plug in your input, in this case, x plus h. So f of x plus h is just a way of referring to y2. So we got two ordered pairs, and we know that if we subtract the y's, so this is y2, f of x plus h, minus y1, f of x, over subtracting the x's. Now if we subtract the x's, we get x plus h. Here's x2 minus x1 is just x. The x's cancel, and that's why you just have an h down below. So difference quotient is just slope. It's defined using this variable h, where h is the amount of change that we see in the x-axis. So to get this simplified difference quotient, we got the form here. We'll start by finding f of x plus h. So to do that, in place of f of x, we're going to write x plus h everywhere we see x. So instead of x squared, it's going to be x plus h squared. And instead of minus 5x, it's minus 5 times x plus h. So here's f of x plus h. Then we have to subtract f of x. So here's f of x. It's two terms, so you want to make sure you have it in parentheses so that you subtract it properly. But there's f of x. And then all three of these terms are over h. So now we have the difference quotient. We just got to simplify it. The way you know it's a difference quotient is simplified is you want to get all factors of h out of the denominator. So we have that h down below. We'd like to cancel it out if we're going to have this simplified properly. So we have three terms in the numerator. We'll handle this first term. This is a binomial squared. So we just want to expand that. We're going to multiply x plus h times x plus h. You can write x plus h side by side with another x plus h and FOIL, or if you're familiar with the form for squaring a binomial, this should be x plus h squared here. Then we'll take care of the next term. This has a minus 5 out front of this x plus h, so we'll distribute the minus 5 in. There's minus 5x. Negative 5 times h gives us a minus 5h. And then I've just got in the third term up top, I've got that negative to distribute across the x squared, and then the negative 5x becomes a positive 5x. It's all over h. So now we can cancel out, let's see, x squared is going to cancel with negative x squared. Negative 5x will cancel with 5x. And that leaves us with 2xh plus h squared minus 5h over h. And now that we've got three terms in the numerator, they all share that common factor of h. So we can pull that h out, and then it'll cancel with the factor we have down below. Right. So again, all three terms up top have h. If I pull the h out, I'm left with 2x in the first term. This was h squared, so now it's just h, and then we have just a minus 5. And now this factor of h will cancel as a factor of 1. So what's left behind is the simplified difference quotient. It is 2x plus h minus 5. So that would be the answer to part A. Specifically 2x plus h minus 5. Now to fill out the table, we might as well just go ahead and plug in x, because x is 5 for all four values in this table. So if I make x 5, I'm going to get 2 times 5 gives me 10. If I subtract this 5, I get a positive 5. And now it's just a matter of plugging in the four different values of h to complete the table. So when h is 2, I get 5 plus 2. When h is 1, I get 5 plus 1. Here is 5 plus 0.1. And here is 5 plus 0.01. And these are the four values that will go in on the table. Thank you for the questions, and hopefully this was helpful. Take care. Bye.